Okay. Jameer, again, that doesn't need to be fully wrapped up right now. Okay, just roll it off to the side and do that later. Ethan, if I see that again, it's going to be a call home. We've got 2 minutes remaining for the connections. Nice focus, Edgar. Damien, we're on science connections. If you don't have it, you're tracking the screen and finding the answers. When you're completely finished, you can give a thumbs up. Johandi's ready to go. Yusuf is ready. Okay, so there's about 1 minute remaining. Brenly is still working? Okay. Manat has a nice level of focus. Good job. Ethan T, come on, let's get it together. Marianne, are you all done? Okay, I'm seeing Edgar, Jace. If for some reason you're just getting settled, please make sure you're on Friday Science Connections. Ten more seconds. Okay. If you flipped your page, come back to Connections so we can clap it out. All right, there we go. Hands up. Let me see them. They're on the screen, so I know you're ready. Thank you, Rodrigo, Jasleen, Jameer, Makan, get them up. Anselmo, get them up. Number 1, clap for A, B, C, D. D. Check. Number 2, clap for A, B, C, D. B. Number 3, clap for A, B, C, D. Number 3 is D. Number 4, clap for A, B, C, D. D. And number 5, clap for A, B, C, D. It is A. So count up how many you got correct. This was out of 5. And show on your fingers, please. 3, 2, 1, show. Makan, nice work. Rodrigo, Ari, Lewis, 100%. Nice work. Nelia, Jace, Damien, great. Wow, lots of 100%. Alrighty, so when you get into your breakout groups later, if you find you had any questions from this review, that would be a great time to bring it up, or from this connection. All right, go ahead and flip your page. Tracking the screen. I just want to kind of remind us of all the different kinds of energy we have heard about so far, although we haven't really learned in depth about all of them yet. So tracking the paper, raise your hands. Which are the types of energy that we have learned a lot about so far? In fact, everyone can start counting, and I want to see on your fingers how many of these on the paper have we like really learned a lot about so far.
Want me to mute somebody?
Sure.
Okay. Justin.
I say 5 because we learned about thermal, and then we learned about chemical, and then we learned about mechanical, and then we learned about potential, and then we learned about kinetic.
So far, we've learned a lot about thermal, potential, and kinetic, which is a type of mechanical. Although we know the others, we're going to have lessons devoted exactly to those. Today will be light and sound. Okay, so we're going to take those one at a time. We're going to read a little bit, and then we're going to add some notes. All right, let's come to our PowerPoint. Tracking the screen. Mr. Vasquez can pick one volunteer to read the science fact of the day.
Esau.
During the avalanches, snow can fall down. Snow can fall down a mountain at speeds of up to 80 miles per hour in just 5 seconds. Avalanches take place when a small amount of snow moves out of place, causing more and more snow to be displaced until a huge amount of snow is moving really fast.
Thank you, Isa. So if you guys can imagine a car driving, 80 miles per hour would be like breaking the law, right? You do not drive 80 miles per hour because it's so fast, it's dangerous. That's how fast the snow can fall in an avalanche. Raise your hand if you think you know what kind of energy we'd be seeing in an avalanche. Agrees, disagrees, not sure.
We have Jasleen C. Unmute.
I think we will see a thermal energy.
How so?
I say thermal energy because since
And do others agree or disagree? I'm not seeing a lot of hands, so let's make sure that your hand is on the screen. Okay, now I'm starting to see some hands are on the screen. You could mute Jasleen back one more time. So everyone repeat after me. When I think of thermal, there's one word I can think of. Say it if you know it. Heat. So agrees, disagrees. Is an avalanche the best example of thermal energy? Show it the thumbs up, thumbs down how much thermal energy snow has. Not very much, and I know because it's cold, okay? So thinking back to the avalanche, Lewis C., I've got you unmuted. What type of energy is it and how do you know?
I think it's sound energy for 2 reasons. One, because sometimes when there's like lots of sound, maybe sometimes things like fall down. Usually.
Pause. I'm still looking, you guys, every time someone speaks that you're showing your reaction. Continue on, Lewis, while I scan for other people.
Because sometimes when it's kind of loud, things fall down. Another reason is you always say the science fact they sometimes need to be connected to what we're going to learn today. So I think that's why it's sound energy.
Oh, so you're just thinking ahead to how it would connect. I like how you're thinking of those connections, hands down. This is not the main energy I'm seeing in an avalanche. So I'm thinking of the detail that says when snow moves out of place, and I'm thinking about how quickly, oops, you know, I should stop sharing this while we're, how quickly the snow is rushing down and it's moving, right? So when I hear moving, what type of energy is it? 3, 2, 1. Thank you, Jade. I'm seeing a lot of
mechanical energy.
but I think this is a really If you're unmuted, guys, make sure you're muted. All right, so eyes on me, because this brings up a really interesting point. Snow does have thermal energy, just not very much. It does have sound energy. It does have light energy. It does have mechanical energy. So how would I know the correct answer? It's going to be the one that I'm primarily seeing or seeing the most. Okay, so although I have a lot of different types of energy for questions like this, Damien, sit up. Want to think about the energy I'm seeing the most. Okay. Coming back to the PowerPoint. Pick up our pencils. We're going to first start by talking about sound energy. So let's jot this down. Sound energy is energy in the form of vibrations passing through matter. Take 20 seconds. Write this on your paper next to the line for sound energy. Jace, can you sit up, please? Take the thing off of your face. Can I see your paper also, Jace? Closer. When did you write that down? When did you write that down?
I wrote it down since I remembered it, so then I wrote it down ahead of time.
All right, so sometimes I'm gonna have really specific ways I want you to write it, so please don't work ahead because I want you to have your page to match what everyone else's does. If you wrote something else and you need to edit it, you should edit it so it's matching this definition. Yes, Louis?
So, Principal, what was the energy for the science faculty today? Because you never told us.
Yeah, the snow is moving and that's mechanical. Sorry, if I didn't say that clearly. Thank you. Okay, let's continue on with sound energy. We have a little reading. Tracking the page, we can take a volunteer reader.
We have Edred.
Sound energy is the noise we hear around us every day. Sound energy in the form of vibrations passing through matter. Sounds occur when objects vibrate. Sound travels through solids, liquids, and gases. Sound cannot travel through empty space where there is no matter.
Okay, everyone take 30 silent seconds to look back over this. Write down, underline, pencils up, and underline a detail you found about sound that's not its definition. Right, tell me something else about sound. Underline it. Okay, now we're gonna unmute a couple people to share their details, and as they're sharing, we're gonna start writing notes into our graphic organizer at the bottom. All right, so your pencil can stay up while people are sharing out, and Mr. Vasquez, you can choose those people.
Unmute check. Check.
I did have the packet. Can you start screen sharing again?
No, because I'm gonna be sharing out my chart this time. We're gonna need to call on someone else.
Okay, so we have Brianna.
What I underlined was sound travels through solids, liquids, and gases.
Cool. We can add that to our chart. Travels through matter. In fact, I had that as one of my first ones too. Travels through matter, solid, liquid, gas.
Okay. Miriam.
Light. Wait, is it the one that starts with
No,
light
Miriam,
energy?
we're sharing out details we underlined.
Okay.
Oh.
All right, so Nana.
What I underline is that sound occurs when objects vibrate.
Cool. Occurs when objects vibrate. Thank you, Nana. That's also in my chart. Everyone's pencil should be moving pretty quick so you get this all.
Ethan A.
I underlined sounds cannot travel through empty space where there is no matter.
Great. Make sure that your chart has these details. It travels through matter. In vibrations. And can't travel through empty space. Ari, are you writing?
Jaden, turn around.
Okay, write it quick, 10 more seconds.
Turned it off, Jaden.
Okay, and on my paper, the last thing I wrote down is an example. Do not write this down. This is really vague. My example is the noises around us. When you get into breakout groups, I want you to come up with your own example that's much more specific, okay? So what do we know about sound energy and what are examples of when we would hear sound energy? We're gonna go into our breakout groups for our 2 minutes, Ms. Nanhu. Okay, sending us out for 2 minutes now.
Hello, I hope everyone had a good lunch and good specials. So I saw Aminat's hand up, I saw Milani's hand up. Let's hear from Milani. What's a good example?
What's a good example is when we put our headphones in our ears and listen to music or something on
Okay,
YouTube.
so pause, agree or disagree. This is a good example. Me too, I agree. So Milani, go ahead and write that down in your chart. Let's hear another one from Madison. Madison, I tried to unmute you. It didn't work. Oh, there we go.
Fine. And you hear people doing the laundry.
Can you repeat that? My computer lagged. Okay. Sorry, Madison, I couldn't hear you. My computer is being...
Another example, you're eating.
Let's hear from Nana. Sorry, Madison. It's my internet connection. Go ahead, Nana.
Another example, we could put what is that when you play a guitar.
When you play guitar, right? So then the sound energy is coming from what? Who can say? Aminat, go ahead and follow up.
Like the stripes, like when you touch it. Can I give another example?
Go ahead. Quickly, Aminat, before we give a session. Yeah, go ahead.
Is that when you're in a cave, when you're speaking or when you're like you're yelling, it's echoing. What you're saying is echoing. Yeah.
Okay. That's a cool one, Aminat. Thank you. So you should all have an example written down in your chart right here. When you have that written, you're returning to the main session.
The screen.
Oscars, you're back.
Well, I thought everyone was back, sorry.
I think we're missing one.
All right, so we're gonna, what I would like to know is one example. Here's what I want to hear. Your example of sound and if that's traveling through solid, liquid, or gas. Okay. So have your answer ready. We're gonna start with Nana.
Nana, unmute it. Oh.
One example
that
Of sound energy is, I think she froze.
Okay.
Let's go to She.
What piece of evidence is that you when you're like using your voice and you can feel your throat like vibrating.
True. So you're speaking and your throat's vibrating. That's actually a little mechanical energy. Now, She is speaking and I'm hearing you, She. So what, well, that's a little, it's different over a video camera, right? But She, your sister hears you. What state of matter is the sound traveling through from you to your sister?
It's traveling through air.
Exactly. So solid, liquid, or gas?
Gas.
Cool. All right, Augustine, have just keep your body still. We're going to get back into the reading now and think about light energy. Before I show out any information about it, let's have one example of a time you see light energy. I think we can probably come up with something before we read.
All right, Milani.
We could think of a light bulb, and that's traveling, I think, from a solid.
You said a light bulb?
Yeah.
Okay, so that's actually really interesting. As we read, think about whether light can travel through a solid. That can be something we think about. All right, light energy. You know what? We're just going right to the reading. We can take down the definition a little bit later. Light energy. I'll start, track the page. Light energy is what illuminates the world around us. It is the only visible form of energy. That's kind of cool. It's the only one you can see. It's the only visible form of energy we have. Usually we cannot see energy, but we can see light energy. You know what? Let's take notes as we go now for a little sake of time. Write down one thing that we just learned about light energy. Go. Only visible form of energy. I'm jotting this onto my paper. Okay, 5, 4, 3, 2, 1, 0. Okay, pencils back down, moving on. We can have one more volunteer reader. Ethan A, go ahead. Got it, Mr. Beth.
Light energy travels in waves. It can reflect off objects and bend as it passes around or through them. Light energy does not need any matter. The level wave does not need the way sound energy does. Light energy can travel through empty space. But
cool, great. So what I'm going to do is have you guys underline 2 things from this paragraph and jot it into your chart. Pencils up. You can do it on your own. Go ahead. Ten more seconds. You can finish the bullet point that you're on. Ethan, can you mute yourself? Oh, I got you. 5, 4, 3, 2, 1, 0. Please put your pencil down. No, you know what? You can leave it up. I'm going to reveal out my chart. If you need to add, you're adding it quickly as we go. So we know it's the only visible form. If you already have it, give yourself a check. It travels in waves. Ooh, we actually didn't write that from the first page. I would jot it quick. Next, it reflects off objects. When we get into breakout groups, you can try and think about an example of that. Can bend as it passes through objects. And lastly, I said it can travel through empty space. So I'm gonna leave these up here so you can see both sides of the chart. In groups, we're gonna quickly talk about light energy, and when we come back, we'll discuss any similarities and differences between sound and light. Ms. Nanhu, let's do, wait, 25, oh my gosh. So teachers, for this last breakout, since it's gonna be our last one, let's go through in breakout groups for 2 minutes. Examples of light energy and one similarity between sound and one difference from sound energy. All right, let's do that now. Okay. Breaking out for 2 minutes.
Okie dokie. Your hands are up. You're ready to answer. Let's hear from Jariel.
One example of light energy, how it like travels or moves is that when you like every time it's dark around nighttime, I turn a lamp and then the light bulb goes on.
Great, thank you. So right for your example, the light from a light bulb, or the light from a light bulb in a lamp. And then for the sake of time, we're going to start talking about some similarities and differences. Take 10 seconds to write this down. I should see everybody writing. The camera should be on. Madison, turn your camera on. Okay. Coming back together, what's a similarity between sound energy and light energy? Go ahead, Milani.
A similarity between both of them is both of them use objects for their own reasons. Like sound energy doesn't travel but uses objects in with matter, and light energy travels through empty space and and reflects the light off.
Okay, thank you, Milani. I'm going to edit that a little bit to say can. Both can use objects or matter, because we know that light energy doesn't necessarily need it. Really quickly, what's the difference? Because we need to go back to the main session. Go ahead, Jane. I tried to unmute you. Can you unmute yourself?
One difference is that sound energy can't go through empty space, but light energy can.
Okay, agree or disagree? I think I'm going to swap that. Light energy can go through empty space and sound energy cannot. Sound good? Go ahead and return to the main session.
While it's open, the multiple choice questions in your IP. That would be questions 1, 2, and 4. Okay, so we have a break and I want to respect your time, but these are important for seeing if we understood this information. So your homework is any multiple choice question on the science. Miss Nana's back.
Miss Lorton is back.
Miss McLean, they don't have a break next.
Oh, I'm sorry. I'm going to repeat the homework one more time because I didn't realize the other groups weren't back. Okay, so you guys, since we're a little short on time, tonight you're going to do 3 problems of science. It's really easy. You're going to do the multiple choice, which is questions 1, 2, and 4. Okay, and while we transition for read aloud, please make sure you're not working on science anymore. Okay, so that's going to be done. We can set it aside and make sure we're really just thinking about read aloud now.
If there's anything you need to quickly go over, we start at 1:15 for read aloud. So if you want, I can also just start earlier.
Oh my gosh, I'm sorry. I was thinking it was 1:05. Well, never mind. That's perfect. Let's do our full IP. Absolutely. Get your science back out. I'm sorry, everyone. I'm so sorry about that. I had the timing wrong. Let's do a timer for 4 minutes. Okay, pencils up, science IP. When the timer goes off, we're ready to go over answers. Yes, Samira?
Materials. I don't have it.
I was just looking to see if I have them. Give me
Okay.
screen sharing has stopped. Hold on. All right, Samira, there's questions 1 through 4. Oh, I thought.
David, eyes on the screen. We're on your work.
About 1 minute remaining. Ethan, are you done? Oh. Jacob, are you done? You could just agree or disagree. Okay. Jasleen C., are you done? Milani, are you done? Can you hold up your paper, number 3? I want to look at it. Milani. Oops. Okay. All right, that is our time. Gonna stop sharing. All right, back to number 1. Hands up. Clap for A, B, C, D. Correct answer, B. Number 2. Clap for A, B, C, D. Correct answer, C. We'll get down to number 4 while we're clapping. Hands up. Number 4, clap for A, B, C, D. C. for number 3 and 5. We're going to just cold call Mr. Vasquez.
All right, cold calling. Soft one.
Soft one, number 3, please.
So, my response was that sound can't travel through empty space because there's no matter in the space, and it said that sound only travels through matter.
Excellent response, soft one. Great job. I think that's so cool, you guys. Imagine that one day you go to space, which could be possible. There's no air, there's no oxygen, you scream. Is anyone going to hear you? Agree, disagree? No, because you can't travel if there's no matter. Okay, let's go to number 5.
All right, cold calling number 5. Shania. Oh, Shania, mute yourself. There you go.
What?
Number 5.
I don't have the packet, but I'm writing it down in the paper, but I don't see the screen.
Okay. Got it. All right, number 5. Try it again. Let's go with Jaden. Go ahead, Jaden. Unmute yourself, Jaden, because I can't do it. It doesn't let me.
The energy releases because the sound energy is vibrating through matter.
Okay. What kind of matter would it be vibrating through if it's the bell ringing?
Sound energy.
And what form of matter would it be vibrating through? Solid, liquid, or gas if you hear bells ringing?
Solid.
So Jaden, sound can travel through the air. You know how you hear a bell? It can travel through water if you're in a pool swimming and you hear people. It can travel through solid. You knock on you listen through a doorway, through a door to see what your parents are talking about. Which one is it traveling through if it's a bell ringing and you're hearing it from over here?
Okay. Gas.
Great job. That's correct. And Jade, I'm gonna look for you. Can you read out for number 6, please? You know what, everyone, let's first clap it and then she'll give her response. Let's clap for true or false. Number 6, clap for true, false. Jade, which is it?
It's false because in the sentence should say light energy travels through waves while sound energy travels through vibrations.
That's correct. Great job. Okay, so knowing those definitions and those words in the definitions will be very important. All right, great. Nice job today. We'll review back over these types of energy tomorrow, and we do not have science homework. All right, Ms. Diaz, take us away.